name is Sophia Lynn. This is Physics 2212 Lab 1 Charge Tape. The purpose of this lab was to prepare charged pieces of clear tape and, after observing their interactions, experiment to determine how much excess charge is on one piece of charged clear tape. To do this, we used three fundamental principles: Newton's law, the universal law of gravitation, and Coulomb's law, and used glow script to model our results. And we found that the charge on each tape was 8.4 times 10 to the negative 9 coulombs, and the number of electrons lost to be 5.25 times 10 to the 10 electrons. The first fundamental physical principle we used was Newton's second law, which tells you that the force is proportional to the change in momentum. We also used Coulomb's law, which tells you that the force of attraction and repulsion between electric charges, as well as the universal law of gravitation, which is the attraction between any two objects with mass, which usually can simplify down to F equals mg. To find the charge of the tape, we rubbed a clear pen against some wool to make it negatively charged, and we found that the charge of the tape was attracted to it, thus making the tape positive. We found the mass of the tape to be 0.0002 kilograms, the length of the tape to be 0.02 meters, as well as the width, and the atom length scale was given to us, which was 1 times 10 to the negative 10 meters, and therefore the atom's area is just that squared, and the number of atoms on the sticky surface of the tape is equal to the tape area divided by the atom area, which gives us 4 times 10 to the 17 atoms. There are two assumptions we made in this lab. First, we assume that both tape A and tape B have the same net charge, and second, to treat each tape as if all of its charge were located at a single point at the center of the tape. And then when we did our experiment, first we used the tape B as our system and tape A and gravity as our surrounding, and we observed that when we brought tape A close to tape B, that the distance between the two tapes was 0.018 meters. And to find our calculations, we used, first we found the magnitude of gravitation on tape B, which is the mass times the gravitational constant, which was 0.00196 newtons. And because tape B was at rest and therefore the net force is 0, we know that the magnitude of electric force on tape B by tape A is also 0.00196 newtons. We then use Coulomb's law to find that the charge on tape B to be 8.4 times 10 to the negative 9 coulombs, and the number of electrons on tape B was found to be 5.25 times 10 to the 10 electrons. Therefore, the ratio of the number of electrons to the number of atoms on the tape was 1.3125 times 10 to the negative 7 atoms per electron. Here was my glow script code. You can see over here we have all of our constants, the variables, the objects of tape A and tape B, and then the force of gravity, which was calculated with mass and gravity, the calculations of charge on the tape, which was Coulomb's law, and then the number of electrons on tape and the number of atoms on the tape, as well as the ratio. And over here we have the electric field function, which gave us this. And you can see that our numbers were pretty similar to the glow script computation results. And you can see here we have the force of gravity as well as the electric force from tape A on tape B pointing up. There are 3 points of errors in this that could have happened in this experiment. First is the loss of charge, where the tape could have touched the surrounding and then lose its charge, which would give us an incorrect experiment answer. And then we also had assumed that there were a equal distribution of charges, but that probably isn't the case in reality. And also, when measuring the distance between tape A and tape B, we could have made some small errors, which would have changed our numbers a little bit. And what if electrons had positive charge and protons had negative charge? Nothing would have changed, because like charged objects will always repel, regardless if it's positive and negative, and therefore the tape will always repel each other because they always have the same charge. And why is it important to handle the charged tapes as little as possible? It's because the tape will begin to lose charge as it comes into contact with the environment around it and start to neutralize, because it wants to gain the electrons that were lost, which would have made our experiment results incorrect.